You can capture changes to large and complex data sets on Hadoop using PowerCenter Big Data Edition. With Big Data Edition, you can distribute the processing of a mapping across Hadoop cluster nodes for high-performance processing in a Hive environment. In this demo, a satellite TV corporation wants to analyze customer portfolios by processing the records that have changed in a 24-hour time period. They want to offload the data on Hadoop, find the customer records that have been inserted, deleted, and updated in the last 24 hours, and then update those records in their data warehouse. Big Data Edition can capture these changes even if the number of columns change or if the keys change in the source files. To capture the changes, we use a workflow with mappings that move the data from local flat files to HDFS, identify the changes, and then load the final output to flat files. Let's take a closer look at the mappings that process and transform the data. The first mapping reads customer data from flat files in a local file system and writes to an HDFS target for the first 24-hour period. A second mapping reads customer data from flat files in a local file system and writes to an HDFS target for the next 24-hour time period. The third mapping captures the changed data. It reads data from HDFS and identifies the data that has changed. To increase performance, you can configure the mapping to run on Hadoop cluster nodes in a Hive environment. The sources in this mapping are the HDFS files that were the targets of the previous two mappings. The mapping uses expression transformations connected to each source to extract a key from the non-key values in the data. The expressions use the INSDR function and the substring function to perform the extraction of key values. The expression transformation outputs key data in one port and non-key data in the other port. The next expression transformations leverage the MD5 function to calculate the hash values of the keys in both files. A joiner transformation joins the two files based on the hash key of the two expressions. The data integration service then filters the data according to whether the data will be inserted, updated, or deleted. If hash key in day 1 is null, but the data contains a hash key and value in day 2, the data will be inserted. If the hash key in day 2 is null, but the data contains a hash key value in day 1, the data will be deleted. If the hash keys of day 1 and day 2 match, and the non-keys don't match, the data will be updated. The data integration service writes the data to 3 HDFS files based on whether the data is inserted, deleted, or updated. The final mapping consolidates the data in the HDFS files and loads the data to the data warehouse. The HDFS files that were the target of the previous mapping are the sources of this mapping. The mapping uses expression transformations to cleanse the data. A union transformation combines the records, and we then load the data to our local file system. When you are ready to run the data warehouse optimization workflow, you can issue the WFS start workflow command to run the workflow from the command line.